2003 Honda Accord blower motor does not work. And let's look at the diagram real quick so we can figure out what the problem is. Here's a blower motor here. We have a power feed coming from this blower motor relay. Blower motor relay is getting power on a power side on the fuse 21 40 amp. The controls it goes down straight to the motor. The control side, you can see, has a constant ground, and now we're gonna follow the other side of the relay on the control side. We're gonna go down to this black and yellow wire, and then we're gonna go down back to a first page. We're gonna go to number 4. Number 4 goes up here and takes us to this fuse number 30, 7.5 amps, and hot in on position, meaning that this control side of the relay is actually activated by this fuse here. As soon as we give the as soon as we turn the key on, that relay is gonna get a power, and it will this fuse will turn the relay on. Now we know the power feed is supplied by the relay, and it gets constant supply as soon as the key is on position or car running. The next step, we're going to look at the ground side. On the ground side, we have blue and black wire that goes into the blower power transistor. This transistor has a constant ground on the black wire, G503. We will check this ground wire here. We have a blue and black wire that actually provides the ground to the motor itself, the blower motor itself. Now once this transistor is closed, it will take the ground through the transistor up to the motor. 2 more wires goes into transistor. Those are control wires. Actually the blue and red wire is actually feedback from transistor to a AC control module. Blue and yellow wire is a control to transistor from AC module. So we have a number 5 and number 6. We will go back to page 1 again. There's a 5, there's a 6, and we have a blower feedback and a blower transistor. So this is our control wire, and this is our feedback from the transistor. So now first thing we're going to do, we're going to go straight to the motor, and we're going to check for power to see if we're getting power from our relay. Blower motor has been replaced already by the owner. He also replaced a 40 amp fuse, and that did not fix the didn't fix the problem. Underneath the glove compartment we have a fan right here. We have those 2 wires, and also we have a transistor here. In order to check the power on our fan, we need to turn the key on, because now we know that relay is only activated when the key is on position, and that should send the power to our fan. Got a key in on position. First we're going to verify the problem. We're going to turn the knob, and this is actually CD inside the radio. It makes noise, but fan is not working. Alright, we can just turn this off, and we can just turn it off for now because the knob controls the ground side. Let's check the power feed. I'm going to take a test light. I got the connected to battery ground through my extension cord here, and I'm just going to touch any of these wires. Should have power feed, because at this point we have open circuit, and we have a power here on this wire, and we have power on this wire. Now let's go ahead and turn the knob to on position and see if sometimes you gotta have a circuit completed, and you can see still we have a good power feed, and so now we need to check if we're getting if we have it a ground. So now we're going to take a test light, and we will connect the test light to positive. So now we're looking for ground. So I'm going to put in positive, and I forgot where's my ground side, but we got nothing here on this side and nothing here on this side either, so we are missing. You can actually unplug the connector if I can. Okay, so now we should have a ground. Got nothing here, got nothing here, and now when we connect my test light on the ground again to see which power, so nothing here, and then this white and blue wire, it's my power feed that comes from the relay, and so now we know that we are not getting a ground to this cooling fan. So the next step we need to go is to go to this relay here. Okay, we have this big black wire, that's our ground. We have seen that on our diagram. So now I'm gonna take a test light, I'm gonna connect the battery positive, okay, and now we're gonna touch that black wire. I can see the and you can see it's my test light is powered, and which means that I do have a ground coming into a transistor. And now the next step, we should have of course a ground on this blue and black wire, but we do not. This wire should take the ground, should send the ground from the transistor to the fan here, but we don't have that. So next is to check our control wire. Make sure that the transistor is receiving command from a AC HVAC module to turn it on, and to do that we're going to use a voltmeter. I'm going to connect it to ground. I don't have a black cable on my voltmeter, but I have a blue, which is okay, so it's on my ground. I'm on the volt, the direct current, and so let's take the back probe and touch that blue, and I forgot what the wire is, but we have 7.5 volts. So let's go ahead and turn the knob to off position, and we still have a 7. So this is actually feedback from the transistor. So you can see either way I turn the knob, I keep turning the knob to on and off position, but this voltage doesn't change. So I'm actually on the feedback wire. That's the one, the bottom left. Now the top left is supposed to be a control wire, and we can see I have a 10 volts on that wire. When I turning my knob, that voltage does not change. And the reason it doesn't change is because the feedback from the transistor doesn't change. It's kind of default mode. So when I turn this into off position completely, it's off. As soon as I turn it to the first speed, it goes straight to 10 volts. So let's start the car. Okay, this voltage will go around 12 volts. Alright, but either speed that I've turned my knob, this voltage, this is off, and this is a first speed, second, third, fourth, whatever. This voltage never changes. It's only this command stays at 12 volts, and the reason it is again because that feedback that comes from the transistor does not change. I'm going back to my back feed wire. Got 8.7 volts. So I'm turning my knob, and there's nothing. Even if there's off, first, second, third speed, the feedback never changes. So now we know that we have a good power feed. We have a good signal command from a HVAC module, but a transistor does not turn on, and so we need a new transistor. We can also use I can use a power probe and touch this blue wire here and give it to a ground and the fan should work. Power probe is connected to the battery. When I press the upper, by pressing this button here, I can actually send power and ground to the tip of this instrument. This is power, this is ground. When I go here, I should see battery voltage, because that's the backfeed from a motor through a relay through the motor all the way up to the transistor. When I give the ground, you can hear the fan is running. So fan is already new, which is not a bad idea to change it. Most of the time when transistor goes out is because of the bad motor. And now we're gonna get a transistor, plug it in, and it should work. This is a Duralast, has a lifetime warranty, so if it goes out, I can just get new one. And so we will plug this in. Let's actually turn off the fan for now. I'm gonna plug it in. Alright, so the resistor is plugged in. Let's turn it on. First speed, second. And the fan is working. So let's go ahead and check our control wire now. So we got, let's see what this is. Okay, this is a back feed. With the system off, we get around 8.5 volts. There's the first speed, second, third. This is the back. This is a signal from the resistor, from the transistor back to the module. And as the speed increases, the voltage decreases there. All right. So basically, that's a voltage drop. Basically, what that is. The less the more the voltage drop, the fan's gonna spin less. The less of the voltage drop, the fan's gonna spin faster. So now let's see the command now from the. So here's 3.5, 2. So as so this is off. There's the first speed. Second. Before we only had like a 12 volts. Third, fourth, fifth, sixth, 7, 8, 9, 10. There's a maximum speed. It sends a signal at 3.5 volts to a transistor, and that's it. So that's how you're gonna check this fan to make sure that it's working the way it's supposed to. And now for fun, we can take a test light. We can connect it to battery positive, and then place that test light to a black and blue wire. I mean blue and black wire that sends the ground to the fan. Battery positive, and then take a test light, and it should light up because now we have a ground. You can see it's working the way it's supposed to. Now as we change the speed on it, that should kind of dim. See that? Because of the, there you go. Because of the resistance in the circuit. So the first speed, second, third, you can see how that voltage is actually increasing, and it's the speed that the fan is spinning faster. So 0, 1, 2, 3, 4, 5, 6, 7. There we go. Okay, well that's it. And now it's just a matter of taking 2 screws out of there and put the transistor in and finish it. All right, guys. Thank you. Bye bye.